So the next topic in information technology, that is virtual reality. So we can tell virtual reality as a high-end user interface that involves real-time simulation and interactions through multiple sensorial channels. So we can tell virtual reality as a high-end user interface that involves real-time simulation and interactions through multiple sensorial channels. See, it involves real-time simulation. So about simulation, we already discussed in chapter number 2. Virtual reality or VR is able to immerse you in a computer-generated world of your own making, a room, a city, the interior of human body. With virtual reality, you can explore any uncharted territory of the human imagination. So in other sense, it's a simulated experience that can be similar to or completely different from the real world. Applications of virtual reality includes entertainment, that is like video games, education, like medical or military training. Other distinct type of VR style technology includes augmented reality, mixed reality, sometimes called as extended reality or XR. Currently, standard virtual reality systems use either virtual reality headsets or multi-protected environments to generate realistic images and other sensations that simulate a user's physical presence in a virtual environment. A person using virtual reality equipment is able to look around the artificial world, move around in it, and interact with the virtual features or items. The effect is commonly created by VR headsets consisting of a head-mounted display with a small screen in front of the eyes, but can also be created through specially designed rooms with multiple large screens. The types of virtual reality. Virtual reality is one of the most promising of today's prominent technologies. While many conversations about the concepts tend to revolve around the environment industry, companies are developing and implementing various types of VR across a range of industries. So the first one, Windows on World or WOW, which is also called as desktop VR. It uses a conventional computer monitor to display the 3D virtual world. Second one, immersive VR. It is completely immerse the user's personal viewpoint inside the virtual 3D world. The user has no visual contact with the physical world and often used with head-mounted displays. The third one, telepresence, a variations of visualizing complete computer-generated world. It links the remote sensors in the real world with the senses of human operator. And the remote sensors might be located sometimes on a robot. It is useful for performing operations which is challenging, which is complex, and sometimes in a dangerous environment. Then comes mixed reality or augmented reality, the seamless merging of real space and virtual space. So it is like mixed one, real and virtual. It integrates the computer-generated virtual objects into the physical world, which becomes, in a sense, an equal part of our natural environment. And then comes distributed VR. It's a simulated world, runs on several computers which are connected over network, and the people are able to interact in real time, sharing the same virtual world. So here, some of the examples or images for telepresence VR. This is a telepresence VR. Augmented reality, this is augmented one, and third one is this is distributed reality. So actually, when we are considering about the types of reality or types of virtual reality, we can have 7. First one is semi-immersive VR. Most of the time, when people think of VR, they picture fully immersive systems like the HTC Vive or Oculus Quest. Unlike these technologies, semi-immersive VR offer users a mix of real and virtual interactive elements. At its most basic, semi-immersive VR is one of the oldest kinds of this technology, but today companies are applying it differently. For example, 4D movies may be the traditional use of semi-immersive VR, but now the technology is primarily used for education. Flight simulators involve a moving cockpit and stimulated environment on screens allow pilots to train without the risk of flying the real aircraft. As virtual reality technology improves, developers can produce similar systems for other complicated tasks or professions. Second one, augmented reality. Like the semi-immersive virtual reality, augmented reality doesn't fully immerse the user, but it differs in that it overlays the virtual and real elements. So overlapping will be there between virtual and real elements. AR application, augmented reality application, display computer-generated items over real-time images of physical environments. Some consider AR as a separate technology from VR, but on a technical level, it falls under the umbrella of virtual reality. So augmented reality shows a lot of promise for several industries. Online retailers can use it to scale 3D images of products onto the user's home. AR goggles can help workers like technicians and plumbers by displaying instructions in the corner of their vision. Similar applications can help teachers make lessons more immersed to the students. So the next one, that is combined or collaborative VR. The next one is collaborative VR. Critics of VR claims it could lead to people becoming too immersed and thus isolated. But the technology can bring people closer together than before. VR takes video conferencing programs like Skype to the next level. This form of VR projects the same virtual environment to several users at once. No matter how far apart they may be. As a result, they can share ideas and work together on projects. Collaborative VR can be as simple as a virtual conference room or as complex as an interactive 3D blueprint that engineers discuss and edit at the same time. Manufacturing VR. Workers can use VR to train in simulated conditions before stepping onto the factory floor. With the right tools, they can decrease the risk of injury when they work with the actual machinery. Medical VR. The most apparent of the benefits of medical VR is that doctors and nurses can train in immersive simulations. Medical staff can use VR to practice surgery in a safe environment with a real-time feedback. VR therapy. Physical health is not the only area of wellness that VR can improve. Treating patients who have psychological disorders can be a complicated process, but VR applications help psychiatrists and therapists explore previously unviable options. Professionals often treat the patients with problems or related disorders with a gradual exposure to the source of the issue, that a process called systematic desensitization of or exposure therapy. And then comes mixed reality. So one of the most recent advanced in virtual reality is the concept of mixed reality. MR, where is mixed reality, is similar to augmented reality in that it combines virtual and real elements. Unlike AR, the virtual components in MR interact with the real world, leading to an authentic, affected VR experience. So some of the technologies of virtual reality, one is head-mounted display. It's a display device worn on the head or a part of the helmet that has a small display optic in front of one, that is monocular HMD of each eye, that is binocular HMD. And head-mounted display has many uses, including gaming, aviation, engineering, and medicine. Virtual reality headsets are HMDs combined with IMU. What is IMU? It is inertial measurement unit. It's an electronic device that measures and reports a body's special or specific force, angular rate, and sometimes the orientation of the body using a combined of accelerometers, gyroscopes, and sometimes magnetometers. IMUs are typically used to maneuver aircraft, including unmanned aerial vehicles, among many others, and spacecraft, including satellite and landers. So we can tell that, see from the picture, it is very clear, it's a helmet or face mask provided the visual and audio displays. It either uses liquid crystal display or cathode ray tube to display the stereo images. It may include built-in header tracker or head tracker and stereo headphones. The second hardware is binocular omni-orientation monitor or boom. So it is one of the oldest VR displays and direct ancestor to the HMD. It consists of a 3D display device suspended from a weighted boom that can swell freely. The viewer holds the viewpoint of the device to their eyes, viewing the 3D environment stereoscopically through it without supporting any of its weight on their neck. The boom position and orientation communicate the user's point of view to the computer. Or in other words, we can tell it's a floor standing device consisting of two rings mounted in such a way that the monitor used to view virtual environment remains suspended in a horizontal plane between them, regardless of its platform motion, similar to device used to a ship to suspend a compass. Then comes Cave Automatic Virtual Environment, which is CAVE. It's an immersive virtual reality environment where projectors are directed to between 3 and 6 of the walls of a room-sized cube. The name is also a reference to the allegory of the cave in Plato's Republic, in which a philosopher contemplates perception, reality, and illusion. So Cave Automatic Virtual Environment provides the illusion of immersion by protecting stereo images on the walls and floors of a room-sized cube. And a head tracking system continuously adjusts the stereo projection to the current position to the leading viewer. Then comes Data Glove, which is also called as wired glove or cyber glove. It's an input device for human-computer interaction worn like a glove. So with respect to the movement of the glove, automatically this also will generate. That means the image will generate or the gesture will generate. Various sensor technologies are used to capture physical data, such as bending of fingers, often a motion tracker, such as a magnetic tracking device or inertial tracking device, is attached to capture the global position or rotation data to the glove or of the glove. These movements are then interpreted by the software that accomplishes the glove. So any one movement can mean any number of things. Gestures can then be categorized into useful information, such as to recognize sign language or other symbolic functions. Then comes control device. It is a control virtual objects in three dimension, X, Y, Z. Some of the software packages available in the market are Multiverse, which is a freeware, which is free of cost. Virtual Reality Studio, which costs around $100. Sense8 World Toolkit, over $1,000. Autodesk Cyberspace Development Kit, that also over 1,000. And VRML, that is Virtual Reality Modeling Language. It allows to specify dynamic 3D scenes through which users can navigate with the help of VRML browser. VRML sensors can be distributed over the World Wide Web and browsed with special VRML browsers, most of which are plugins for Netscape or Internet Explorer. So this is the architecture of the VR system. It contains an input processor, a simulation processor, a rendering processor, and a world database. What are they? What is input processor? It controls the device used to input information to the computer. So it accepts the inputs to the computer. The object is to get the coordinate data to the rest of the system with minimal lag time, means minimal delay time. We are for input as an input processor, we are using keyboard, mouse, 3D position trackers, voice recognition systems, etc. Then comes the simulation processor. It is a core, it is the main of the VR system. It takes the user inputs along with any tasks programmed into the world and determine the actions that will take place in the real world. And third one is rendering processor, creates a sensation that are outputs to the user. Separate rendering processors are used for visual, auditory, haptic, that is touch, and other sensory systems. Each renderer takes a description of the world stats from the simulation process or derive it directly from the world database for each time step. So what is world database or world description files? So it stores the object that inhabit the world, scripts that describes actions of those objects. And then comes the different applications. We can use it in entertainment, which is more vivid, more clear, more exciting, more attractive. In medicine, we can practice perform surgery on a remote patient, teach new skills in a safe and controlled environment. Manufacturing, easy to modify, low cost, and highly efficient. In education and training, driving simulators, flight simulators, ship simulators, tank simulators, etc. And the problems and future work, the cyber sickness or simulator sickness, we can tell low fidelity, expensive, lack of integration between application packages. And the future works like high fidelity system, cost saving, collaborative, high level contact between participants in distributed VR. That's all about this chapter. I think you got the concept clearly. If you're having any doubts, please write to me to my email address, which is provided in chapter 1. Thank you for listening. Thank you.